It's a very long title. Solving equations and inequalities using logs. So remember last time when we had an equation or an inequality like 2 to the x equals 4, and you change the other side to a base of 2, so 2 to the x is 2 to the 2, and therefore x equals 2. Remember that? Okay, so this time we're going to solve equations similar to that, but instead of changing the other side to the same base, we're going to use logs. So, for example, we have 2 to the x equals 11. So, what can we do to this 2 here? Take it over the other side. What would it become?
Log base 2.
Yeah, log base 2, and then you raise the 11 up. So we're left with x. We have our base of 2 becomes the base of the log, and we don't raise up the 11. The 11 is just the number. So log base 2 of 11. Now, log base 2 11, that's something that you would just do on the calculator. And if you type it in exactly how you see it, you get 3.46. Now, there is a different way to do that, and that's by taking log base 10 of both sides. So if we start again with the same question, what we can do is take log base 10 on both sides. So this side obviously becomes log base 10 of 11. And this side, when you take log base 10, the x comes down in front. So x log base 10 of 2. And as x is being multiplied in front here, we can just take the log base 10 of 2 over and divide it. Right, and if you were to do that on the calculator, you should get the same answer. If we were asked to do it without the calculator, well, without the calculator, you generally start with a log and work backwards to find the question. So you won't find these types of questions on the test because the test is non-calculator. Another one. 3 to the power of 2x minus 1 equals 28. Okay, so we take the base of 3 over, and that becomes log base 3. So we're going to have 2x minus 1 equals log base 3 of 28. And then all you have to do from there is just, as normal, rearrange to find x. So we're going to take our minus 1 over, it becomes plus 1. And then we're going to divide by 2. Or to make it look a bit prettier, I'm just going to times by half. Oh, can you do that? No, it'd have to be brackets. Because you want the half multiplied to the 1 as well. Okay, that's obviously a calculator question. 2.017.
Is that log 3 of 28?
Yeah. Plus 1. Now, the other way to do it, you can take log base 10 on both sides. So if we start again with the same question, taking log base 10 on both sides, what would you get? Yeah, so the power comes down. Log base 10, 3. And then just log base 10, 28. Once again, just rearranging like... right, so here, from here, we just rearrange to find x. So we're going to take our log base 10, 3 over. And then we can add 1. And then divide by 2 or times by half. And you'll see that you get exactly the same, oops, not 3. Exactly the same number as before, so 2.017 on the calculator. Okay, so an easier one. I mean, this one's going to be pretty basic, but it kind of gets the point across, I think. So now we could do it the first way by making an 8 a 2 to the 3, and then obviously x equals 3. But if you wanted to do it the log way, you take this 2 over, and it becomes log base 2 of 8. And then this side is saying 2 to the power of what equals 8. Essentially, like you're pretty much doing the same thing as before. So that's 2 to the power of what equals 8, and it's, yeah, 3. Yeah. Find the ones that you probably do in your head are really straightforward because you pretty much just go back to the question. Log base 2 to the 8 is saying 2 to the power of what equals 8? And it's 3.
Oh.
2 to the power of 3 equals 8.
What to the power of 2?
No, 2 to the power of what equals 8? Did I say it the wrong way around?
I think the first time.
Yes, so x log base 10 2 equals log base 10 of 8. Can you do, I don't know, I don't think you can do that because it's 10 to the power of what equals 8. Yeah. Yeah. Okay, so now about inequalities. Now I have made a slight error on the sheets that I've written for you. So all you need to do is amend it so that it says when you take a log over the other side, the inequality symbol changes direction when the base is between 0 and 1. So if it's more than 1, it stays the same. So when the base number is between 0 and 1. And I'll explain why. Okay, so it changes direction when the base is between 0 and 1. You can say it like that. Okay, so for example, we've got 0.7 to the x greater than or equal to 0.3. So you would solve this by just taking the 0.7 across, and that becomes your base of your log. But because it's between 0 and 1, the inequality changes direction. So it's now going to go that way. And that is something that you would do on the calculator. 3.38. Or if you were to do it the other way and take log base 10 of both sides, you get x log base 10 of 0.7 log base 10 of 0.3. Now, what is actually log base 10 of 0.7? Yeah, so this number here is actually a negative number. So when we take it over the other side, we're dividing by a negative number, so that means that the sign flips. So you get 3.38. So for example, if you were to do it this way, 2 to the x is greater than 8. When you take the 2 over and it becomes log base 2 of 8, the 2 is obviously greater than 1, so the sign stays the same. It's only when the base number is between 0 and 1 that the sign flips. Okay? That's it.
Does it still equal 3?
Yeah.
So even when you divide, it stays the same.
Only if it's
Only
above 0.
So it'll be that. Sorry?
So anytime you divide and it's above 1, it just stays the same.
Stays the same. Yeah, the sign doesn't flip. It's only when it's between 0 and 1 that it flips.